All right, you may have seen this one before, but if you haven't, it really is a very simple and important concept in trigonometry. It's called the law of sines. The law of sines allows you to identify the lengths of sides of triangles or the angle measures of the sides of, or of the angles of triangles when it is not a 90-degree angle, when it's not a right triangle. Now, it does work on a right triangle, but there are better techniques than the law of sines to use on right triangles. But what happens when your triangle is not a right triangle? So we can see here angle A here is not a right angle. It's larger than a right angle. That makes this an obtuse triangle. Now, it does not have to be an obtuse triangle. It can be an acute triangle as well in order to use the law of sines. What the law of sines basically does is it creates a proportion between a side length and the angle measure that is across from it. So you can see here we have angle A, so the capital letters are the angle measures, lowercase letters are the side lengths. So angle A is across from side A. Angle B is across from side B, and angle C is across from side C. And what the law of sines basically says is that there is a proportional relationship between the length of the opposite side and the sine value of the angle that's opposite of that side. Okay? And the way it works is this, is that the proportion, the fraction sine of angle A divided by the length of side A is always going to be equal to the sine of angle B divided by the length of side B. And that it will also be equal to the sine of angle C divided by the length of side C, okay? And this proportional relationship exists in all triangles. It is built into the fabric of the universe, this proportion among the sine of the angle divided by the side length. Now here's the interesting thing. So these are proportions, and what I want you to understand is you don't need all three of them to solve it. Notice that this is equal to this is equal to this. That also makes this one equal to this one, okay, by the transitive property. You only need two of them. In order to solve a problem, you really only need that one, or that one, or that one, okay? You only need two of them, and I'll show you that in just a couple minutes when we solve a few problems. Now, here's the other interesting thing about proportions, is that as long as it's a fraction equals a fraction, that is a proportion conversion, or a proportion. You can just flip over the fractions and it's still true. So inasmuch this, sine of A over A is equal to sine of B over B, we can also say that A over sine of A is equal to B over sine of B. I'm going to give you a very simple example of that. We know that 3 over 6 is equal to 1/2, right? We can reduce 3 over 6 to 1/2. Or, we could, if you wanted to, we could also say it's the same thing as 5 over 10, right? 3 over 6 is 1/2, 5 over 10 is 1/2, therefore 3 over 6 is equal to 5 over 10. It's the same thing, right? Well, what if I flipped them over? What if I said 6 over 3? Is 6 over 3 equal to 10 over 5? It sure is. So whenever you have a fraction equals a fraction, and that's all it is a fraction equals a fraction, you can just flip the two sides over. I know I've said that before, but I'm just reminding you again. So the law of sines can be written as with the signs on top or with the signs on bottom. It doesn't really matter. You'll still be able to solve the problem. You'll still get the right answer, okay? So let's do an example of why we would use the law of sines, how we can use the law of sines to be able to answer a question. All right. So I've gone ahead and filled in some numbers here. I put a 10 down here. I put 100 degrees up here in angle A. Side B has a measure of 7. And the question is, what is the measure of angle B right here? Okay. Now, once we know the measure of angle B, we can then determine the measure of angle C. We can find the length of side C, all kinds of fun stuff. Now, I want to warn you, to find the length of side C, we cannot use the Pythagorean theorem because this is not a right triangle. Pythagorean theorem is only for a right triangle. So to find the measure of angle B, because we know angle A and side A, okay, you want to figure out, well, which of the letters do you know both the angle and the side? Okay, because you're definitely going to use that one. So we have the angle measure of A, and we have the side length of lowercase a. So we're going to use both of those. So we're going to use sine of A over A. So we're going to set this up as sine of A, which is sine of 100 degrees. Now we're doing this one in degrees, but you can also do it in radians. Divided by the length of side A is 10, so we'll just put a 10 down here, equals. Now you want to know, well, which one are you trying to solve for? Well, we're trying to solve for the measure of angle B. So we're going to put over here sine of angle B. And in order to solve for the measure of angle B, we're going to need to know the length of side B, which is 7. Okay, so we're going to put a 7 down here. Now, if we did not know the length of side B, we wouldn't be able to answer this question. You're going to need to take at least 2 of these. Usually it's always going to be 2 of them, and you have to be able to fill in for 3 of the things. You got to fill in for 2 angles in one side or 2 sides in one angle. So in every situation, to be able to answer these questions, you either need 2 sides and 1 angle to solve for an angle, or 2 angles in one side to solve for a side. Okay? So we have this, and now all we got to do is a little bit of algebra. Okay? So we're going to multiply. We can cross multiply here. You're familiar with cross multiplication, right? Or we can just, very simply, we can multiply by 7 on both sides. That's a little bit easier. If we multiply by 7 here, it cancels. Multiply by 7 here, and now we get 7 sine of 100 degrees. Okay? Divided by 10 is equal to sine of B. Now, here's the thing. We can get a number here. We can just key this into a calculator and get a number. Okay? But that's not going to tell us what B is. That's going to tell us what sine of B is. And so in order to do that, do you remember when we were doing inverses? Like if I had sine inverse of 1/2, I was able to cancel the sine by doing sine of both sides. If I did sine of this, it would cancel the sine inverse out. Well, just as much as sine cancels sine inverse also cancels sine. So here I can do sine inverse of this, and I would also have to do sine inverse of this. All right, sine inverse of this. So this is going to cancel sine, and now I get B is equal to sine inverse of whatever this is. Well, I'm going to need to key that into the calculator so that I can get a value. So I'm going to grab a calculator. I'm dealing in degrees. So I'm going to make sure my calculator is in degrees. Good. And I'm going to do, first thing I want to do is I want to find out what this value is. I'm going to do 7 sine of 100. 7 sine of 100 degrees. That's going to give me 6.89365. Now, I do not want to round at this point. You do not round until you get to the final answer, okay? So what I have so far now is going to be sine inverse of 6.89365427. And I'm going to divide this by 10 on the bottom. And all that's going to do is move the decimal point over one place. So divide by 10. And I get 0.68936. So B is going to be equal to sine inverse, which I'm going to key in the calculator in just a couple minutes, of 0.689365427. Okay? Now I'm going to key this in the calculator, sine inverse, and I can really just put in, there's a button on here that says use the last answer, so I'm going to do that. And it gives me B is equal to 43, and I'm going to round to 2 decimal places, 43.58 degrees. So the measure of angle B is 43.58 degrees. Then that now tells me if I can add this plus this, subtract it from 180, and that'll give me angle C. Okay? All right, let's try another problem. All right, so we've got a length here. Side B is 100. Side C here is 90, and angle B has a measure of 37 degrees. And we want to know what is the measure of angle C. Obviously, it's going to be in degrees, so make sure your calculator's in degrees. Do you want to pause this and maybe try and do it on your own? It's just like the last one we did. Okay, so I'm going to go ahead and use, well, just for fun, no, you know what, I'll use the exact same one, only this time we're using B and C instead of A, so we're going to do sine of B over B is equal to sine of C over C. So sine of B over B is equal to sine of C over C. And sine of B, okay, so angle B is 37, so we're going to do sine of 37 degrees, okay, over the length of B is 100. 100 is equal to sine of C. We do not know what angle C is. We're trying to find that. Over the length of C, side C is 90, okay? And so we're going to multiply by 90 on both sides to cancel. Multiply by 90 on both sides. And so now we have sine of C is equal, sine of C is equal to, I'm sort of putting this on the right side just so that I can have my variable on the left side. I'll now have 90 times sine of 37 degrees, 90 times sine of 37 degrees over 100, okay? So now, let's go ahead and calculate this before I do the inverse. I'm going to do 90 times sine of 37 degrees. That gives me 54.1633528. I'm going to divide by 100. And that gives me, on this side, 0.5416335. Let's stop there, okay? And so now I know that sine of C is equal to this. Now, I need to isolate C, get C all by itself, so I need to cancel the sine. Well, remember what I said, the way I cancel a sine is I do a sine inverse to both sides. So I'll do sine inverse over here, that'll cancel sine. I also have to do a sine inverse, sine -1 inverse of this number, and so now I get C is equal to sine inverse of 0.5416335, which I can now just key in the calculator. So sine inverse of 0.5416335, and that gives me C is equal to 32, I'm going to round to 2 decimal places, 0.79 degrees, and that is the measure of angle C, okay? Let's try another one. All right, so on this third example, we're going to do it in radians. We're going to find what is the measure of angle A right here. But we're going to do it in radians, so we're going to get our calculator and we're going to hit either mode and switch over to radians, or we're going to hit the DRG button and switch over to radians. So now we're in radian mode. We're not dealing in B at all. We've got the measure of angle C, we got side C, we got side A, and we want to find the measure of angle A. Okay, so we're going to use sine of A over A is equal to sine of C over C. All right, so sine of A over side A is equal to sine of C over side C, okay? Just a proportion between the angle and the side. That's what trigonometric functions are. They just create their constant proportions between sides and angles, okay? All right, so sine of A is what we're solving for A. So we'll just put sine of A. The length of side A is 55. Okay, 55 is equal to sine of C. Well, C is 0.52 radians over the measure of side C, which is 29. And now we're going to solve algebraically. We're going to multiply by 55 on both sides, cancel, times 55 here. And we're going to bring this over. So we got sine of A is equal to 55 times sine of 0.52. So I'll put that in the numerator, 55 sine of 0.52 radians. Okay, over 29. Okay, so now we got sine of A is equal to, I'm going to do the numerator here, 55 times sine of 0.52 radians. I'm in radian mode. That gives me 27.3284. 0758 over 29. So now I'm going to divide this number by 29. Divided by 29 gives me, well, let's bring it down, equals 0.9423, 9423, 589. 5, 8, 9, and sine of A. All right, well, how do I cancel the sine? I need to solve for A, angle A. How do I cancel the sine? With sine inverse. Sine inverse of this, cancel sine. I also have to do sine inverse of this side. So what I have now is A is equal to sine inverse of 0.9423589. Okay, so if I do sine inverse of that number, I get A is equal to 1.23 radians. Remember, that's radians. Okay? So A is equal to 1.23 radians. Okay? Which is actually less than 90 degrees. It looks like it's obtuse, but according to this, it is not obtuse. Sometimes the drawing can be off from the actual calculation. Okay? All right, so what I've got here is I've got two angle measures. I've got 0.47 radians in angle C. I've got 0.7 radians in angle B. Side C is 15 long, and now we want to know what is the length of side B. Okay, so we're going to use the law of sines. So we're going to use sine of B over B is equal to sine of C over C. Sine of B, B in this case is 0.7 radians. We want to make sure that our calculator is in radians. I am in radians already. Okay, over B is equal to sine of C, which is 0.47, so sine of 0.47 radians, over the length of C, which is 15. And now I've just got a proportion, I've got an equation, I'm just going to solve it. I'm going to multiply by B on both sides. Well, sort of. Actually, you know what I'm going to do? It's going to make it easier to solve. A couple ways I can do it. I can flip this over. Really, if I use this one instead of this one, where my solution variable is in the numerator, it does make it a little easier to solve. So let's switch it up and make it B over sine of 0.7 is equal to 15 over sine of 0.47. Okay, now all I have to do is multiply by sine of 0.7 on both sides, cancel, multiply by sine of 0.7 over here, and now I have B is equal to 15 times sine of 0.7 divided by sine of 0.47. Now listen to me. You cannot cancel these signs. Just because you have a sign in the numerator and a sign in the denominator, you can't cancel them. That is a polynomial quality. This is, now if it was sine of 0.47 in the top and the bottom, then you could cancel it, okay? But this is transcendental. This is sine of 0.7 and this is sine of 0.47. Those are different numbers. They do not cancel. Just work it out as is. Okay? So I'm going to do 15 times sine of 0.7, and I am in radian mode. And I'm going to hit enter, divided by sine of 0.47. And that gives me 21.34. And that is the length of B. So this length over here is 21.34. Okay? Let's do one more length problem, and I think at that point you should have the hang of this. All right, so we've got this triangle here. We've got angle A is 104 degrees, so we want to be in degree mode. So I'm going to hit the DRG button here, move over to degrees. You can go into your mode button and change to degrees from radians if you have to. Then angle B is 39 degrees. The length of side B is 219, and we want to know the length of side A. Okay, says what is the length of A? So we're going to use the this one right here. And remember what I said, to me it's easier to use this version of it when you're doing length, and it's easier to do this version of it when you're doing angle. So I'm going to use this. A over sine of A is equal to B over sine of B. So A over sine of A is equal to B over sine of B. Okay? Now, angle A is 104 degrees. So I've got A over sine of 104 degrees, and I'm in degree mode, is equal to B, length of B is 219. 219 over sine of 39 degrees Okay? And now I'm going to cancel the sine of 104. So I'm going to multiply by sine of 104 degrees on both sides, cancel, times sine of 104 degrees. And that gives me A is equal to 219 times sine of 104 degrees. Okay, over sine of 39 degrees. Now I cannot cancel these sines because they're sine of different angles, but I can now do 219 times sine of 104 degrees. I'm in degree mode. Enter. Now I'm going to divide that by sine of 39 degrees. And that gives me 337.66 is the length of A. This is 337.66. And we use the law of sines to find that. Very, very useful proportion here, and I'll give you plenty of practice so that you can be really good at it. And then this is going to help you in the next thing we're going to move into, which is going to be pretty soon. It's going to be solving trigonometric equations.